move on to tool number 6. And tool number 6 and tool number 7 are the same tools as tool number 3, but their orientation's different. And one's a left-handed tool and one's the other is a right-handed tool. So we're going to first copy the right-handed tool, and we're going to use all the same information. So we're going to take and go back to our library. And we're going to do a right click on tool number 3, and we're going to duplicate that tool. Now right now it's giving us an error because we have two identical tools in there. So let's go in and edit the second one. We're going to say edit, and in general what we're going to do is we're going to call this a facing tool. So face turning tool. Okay, this has got a different name, same part number. We're going to go to our insert, that's going to be the same. The holder is going to be identical. Okay, and our setup though is we're going to be facing the spindle in this case. And we're just going to leave the feeds and spindle. Okay, now we shouldn't have a conflict there. Alright, so now we want to take that same exact tool and we're going to make a left-handed version of it. So we're going to duplicate it, we're going to get our warning, and we're going to go into edit, and we're going to go to tool 7, and then we're going to go to the holder type, and we're going to just keep everything the same, but we're going to make it a left-handed tool. Instead of going to be a right-handed tool, it's a left-handed tool. And it's still made by Hurdle, but or Hertel, left the R out, but the part number is different because it's a different orientation. So the insert's the same insert, but the holder's different. So we're going to go back to our tool list and we're going to look for the left-handed version. And again, the insert's the same, but we need to put in this number, this one here. And we're going to copy that URL and replace this one with it. Actually, the way MSC does it, you could have just replaced the end of it, which is the number, and you would have got the right thing. There we go. So now we have a right-handed indexable face turning tool and a left-handed tool. That way we can machine features on the face of the diameter. All right, moving on. We have now 7 of these, and we're going to march on to do the next one, which is number 8. Okay, so magazine number 8 is a right-handed outside diameter indexable threading tool holder with a 632 insert. Okay, so we're going to take that and we're going to go bam, and we're going to go. Okay, so we're making a new turning tool. All right, it's tool number 8, our description. Okay, right hand OD threading tool. I think we should put 632 at the beginning. 632 right-handed outside diameter indexable threading tool, and then we're going to chop off the end of the description. Okay, and the vendor on this was Hertel as well, or Hurdle, however you want to pronounce it. So we're going to pick on our tool body, and so this is our tool, and we want that part number to be here. Or no, we're not. We're going to hit our insert. So it's going to be a threading tool. And it's triangular. Okay. So triangular full profile. That's what it looks like. And our thread pitch is going to be 0.03125. Okay, so we got our insert number. It's the 44056539. And our insert is iso triangular full. Our thread pitch is 32 threads per inch. And then our inscribed angle according, this is a number 16, so it's 3/8 is the length for L. So that's 0.375. Okay, and our insert width according to the catalog is, thickness is 146 thousandths. Which I would think would be also the width on this. I'm not sure where that's coming from. Okay, we're going to go to our holder, 1-inch shank. Okay, I'm going to setup, and it's going to be facing as default here. Facing forward. Feeds and speeds. We'll leave that at 500 RPMs. We don't want to go too fast with this for threading. And we'll select OK. And now let's take a look at how a threading tool works. We're going to return to our example machining that was in progress. Now it's switching to a threading tool, and it's doing a thread very quickly. It's hard to see at the resolution of this video, but it's cutting an outside diameter thread there. So now we're on to tool 9. Tool 9 is, okay, so it's a number 40 drill. Okay, so this is where we're going to start copying stuff. We got a whole bunch of drills. Hopefully it should go faster. They're all going to be held in the same kind of holder. So let's go to our spot drill and let's copy it to be the number 40 drill. We're going to go to our spot drill and we're going to duplicate it. And we're going to edit that. Number 40 drill. And we're going to take the material out. We already have that designated. We're just going to say stub length. Okay, number 40 stub drill. We're going to go back to our chart, and our number 40 drill is 98 thousandths. So drill bit. Our angle is going to be 118 degrees. Our diameter is 98 thousandths diameter drill, which is the number 40. Okay, and we're not going to bother with the part number on this one. These are commodity drill bits, so I have my list, but our overall length is 2 inches and 3/8. 3/8, and the body length, I'm not going to change that yet. Our shaft diameter is 98 thousandths also. Our flute length, which would be our cutting length, is 1 3/8. Okay. Okay, so for shaft, we're just leaving it alone. For holder, we're going to leave it alone. It's going to use a different collet. Holder geometry, feeds and speeds. We're just going to leave all at the same. All right, so we're going to hit, and this is not a live tool. Okay, because it's on a lathe. 3/32. Okay, so the next tool is your 3/32 drill bit. I'd like you to copy the last drill we just did, the number 40, and change the parameters for the 3/32. Should be pretty straightforward. I don't need to walk you through that every step. I do want to note in the tutorial I did make a mistake, and we will not have enough tool positions, and so please reference the tool positions that are in the spreadsheet for this subsequent tools. If you do follow the tutorial and get the numbers incorrect, that's okay. And towards the end of the tutorial, I have you renumber them, but it would save you a step. So the previous tool that was just put in is supposed to be in position 9, not 10. But then the 30/32 is also in the position 9. Those tools will have to be swapped out depending on which program is being run. All right. Reference the previous part of this tutorial if you need help duplicating this drill bit. So you can pause the tutorial here to complete that work, and we'll pick back up with the tutorial for the following tool, which is a reamer. Let's copy this description. It's number 4, 4-flute reamer. We're going to copy that description. We're going to go back to Fusion, HSM, and this time we're going to do a new mill tool, and it's going to be tool number 12. We're going to go ahead and put in our description, and we're going to take out the material. So high-speed steel. Take out straight shank. Number 41, 4-flute chucking reamer. Okay, this is a specialty item, so I do want to put the order information on here. So we're going to go back to our spreadsheet, and we're looking for the reamer. And it looks like it's this. And go back to MSC. Okay, there's our information. We've got our specs. We got our reamer diameter. It's 96 thousandths. Copy that. So we got our diameter there. We're going to change it to a reamer. So it changes the look of it. We're going to go back to general. And I want to get the product ID. That's hurdle. This is not a live tool. We're going to go to the cutter, and let's put our overall length in first. So what a reamer does is it goes in after a drill bit, opens up the hole, but much more accurate and a better finish. So our overall length is 3.5 inches. Our diameter is 0.096, and then our flute length is 7/8, which is 0.875. Our shaft diameter here is 0.0918. Okay, so we got all our parameters in. We're not going to worry about our shaft diameters here. We could add a segment to more accurately simulate this, but we're not going to worry about it. Okay, and then the holder we're going to select is going to be the same one we've been using before, the ER32. And we're just going to leave this at default. It is 4 flutes. Actually, no, I'm going to slow that down. I'm going to slow that into 20 inches a minute. That's not a live tool. It's not spinning because it's in a lathe. Okay. All right. Now we're done with that one. Okay, your next drill bit is the 7/16 drill bit. I'd like you to copy the last drill we just did and change the parameters. Should be pretty straightforward. I do want to note in the tutorial I did make a mistake, and we will not have enough tool positions, and so please reference the tool positions that are in the spreadsheet for this subsequent tools. Those tools will have to be swapped out depending on which program is being run. Alright, reference the previous part of this tutorial if you need help duplicating this drill bit. So pause the video here and pick back up when you've completed the 7/16 drill bit. Chart, and now we're doing a 7/16 ball end mill with 3 flutes. So let's go ahead and grab that description. Ball nose end mill. We're going to do a new milling tool. We're going to put in our 7/16 ball end mill. We're going to erase the 3 flute off the description. And this is a specialty thing, so I do want to have the correct part number. Okay, we're going to go to here, and an end mill cuts on all sides but has a spherical tip to it. Okay, and this is to make our inside radius on the primary piston. If shell, it's got a a spherical end in it. Okay, so we're going to take this information and we're going to go. It's 7/16 in diameter. It's 3 flutes. It has a length of cut of 2 inches, but the overall length is 4 inches. Okay, but we want this product information, and let's remember that our overall length is 4 inches. And the vendor was Titan USA. And I don't think that's Titan from Roseville. Okay, and then our tool number is 14. Okay, and this is carbide. It is not a live tool in this instance. We're going to go to the cutter, and it's going to be a ball mill. Okay, and our diameter is going to be 7 divided by 16 with an overall length of 4 inches with a flute length of 2 inches. Okay, and our shank was the same diameter. And I think we're good there. We're going to leave the shaft alone. The holder, we're going to select that ER32. Okay, and there we go. All right, so now we got tool 14. It's a ball end mill. Again, that's going to go axial in our turret. Okay, so let's take a look at the orientation of this ball mill. It would be in a position that's axial. So it would be pointing towards the spindle in the turret, similar to tool number 3 in the image. The image is showing I believe it's a boring bar or a drill, but it would look similar to that in size. And we need to override something. We need to go back and look at our tool numbers and what turret position they go in there. Once we hit 12, we've used up all our magazines. So we're going to use, if you recall, we're going to alternate numbers on here. So it looks like we went out of sequence. So tool number 10 is actually tool 9. Let's look at our list. What did we screw up here? 9, 9. Okay, so the Reamer is tool 10. Diameter offset is going to be 10, and our length offset is going to be 10. Okay, so let's double check our work here. So we have number 9, and the number 40 drill is tool number 9. The 3/32 is also tool 39. Okay, so this is going to be 9. And then the number 40 drill is 9, but the Reamer is number 10. So then we're going to go to the 7/16, so 9 and 10. And the 7/16 ball will also be a tool number 10. Okay, it's marking them orange because it's warning you using the same numbers over and over. But in this library, we're not going to be using those tools simultaneously in the machine. So provided we load the correct tool in the machine, our programs will match. So we only have 12 positions in our turret. Okay, so sorry about that. Now we're going to move on to our next tool. Okay, so we have another drill bit to make. It's the number 36 drill, and that will be the tap drill for the 632 thread we're going to do. So I'd like you to stop the video here and copy one of your previous drill bits and change the parameters to match the parameters for a number 36 drill. And then you can return to the video for the next tool, which is a 632 tap. The 632 plug tap. So let's highlight all of that, and that is going to be tool number 10. So we're going to do a new mill tool, and it's going to be a right-handed tap. And we're going to go to general, and it's going to be a tool number 10, high-speed steel. Put in our description, 632 plug, right-handed tap. So we're just going to put a we're just going to put 632 machine tap. We do want the vendor, which it should be OSG. That's actually wrong, but we'll go to the information on the actual tap. So the company is OSG, and the product ID is there. There's our product. our cutter. It's going to be the major diameter is the same as a 632. So the major diameter on a 632. Okay, according to our handy dandy drill chart, a number 6 wire is 240 thousandths. Our thread pitch is basically 1/32 of an inch at 32 threads per inch. Our overall length, according to our catalog, overall length is 2 inches. Our flute length, or cutting depth, 11/16. Our shaft diameter is 141 thousandths. Okay, so I put in 0.7, a little bit more than the flute length for the body length. I don't think it's worth going in and adding to the shaft to make it look more like a tap, but this is what it's going to model as. In our holder, we're going to again select that same ER32 holder. So it's a Meritool Cap 40 E32 1 inch 0.85 gauge length. Okay, and then there's our holder. And the feeds and speed should auto calculate based off the actual tap cycles. Although 5,000 RPM is a little fast, that scares me for a tap. So let's put in a 1,000. I don't want to see it go any faster than that. Alright, so we got tool number 10 and is not a live tool, and we're going to hit OK. Alright, so we've got a lot of tool 9s and tool 10s, and now we're going to move on to what our next tool is. Okay, so now we have a series of drill bits. And so what I would like you to do is between this video and the next video, before you go to part 4, is to generate the drill bits for the number 48, the 51, the 9/16, and the number 9. You should be able to reference the prior tutorials on how to copy those, and make sure you reference the turret numbers that are on the spreadsheet, and you should be good. And then the very last segment, which is part 4 of this, you'll build the inside diameter grooving tool. See you in the next video.